Hi there. So, in my UPS battery restoration video I talked a bit about ordering some stuff to help my workshop get a bit more energy efficient. Well, this is the box of goodies, so let's tear it open. I already looked inside because I got too excited. And anybody who's dealt with the Chinese before will recognize the Shaw Electronics logo. And these switches aren't what we're looking for, although they're going to come in handy. We have some fancy boxes with one and a half amp LED drivers, or configurable LED drivers, 150 to 1.5 amp you are supposed to set different jumpers. 150 plus 300 gives you 450 and so on. I think I've got 10 or 20 of these, but the real fun stuff should be in these. Does it say anything here? No, these aren't the real fun. These are my 1 watt warm white LEDs, about 80 lumens per watt. They have this for very cheap, 10 pack. So let's have a look at them. There we go. Cute little warm white LED. These might go in some places where I don't need too much light and might be moving around at night where I don't want to install. Let's see if we can find them. No. And I don't want to install one of these. 10 watt cold white LEDs. These cost almost nothing. And they are still specified to be fairly efficient, about 80 lumens per watt. And these, as I said, I can't recall how many there are, there might be 10 or 20, are going in my workshop. I'm not entirely sure how to mount them yet, but they are going to replace my horrible, cheap, warm white, compact fluorescent lights. And when I couple them with a few of these, and I hope this is it. There we go. Does it say anything? Yes, it does. A very efficient 87% about 42 volt power supply. I'm going to end up with a pretty nice lighting system. This is just a Bluetooth module order for a friend, and the rest is just LED drivers. So, there are some more bags in here, some of the 1 watt ones. And here are 5 3 watt warm white LEDs I took just because they cost nothing, in order to see if they're any good. I might use these to LEDify a incandescent light we have in the kitchen, which tends to run a lot at night and is wasting quite a lot of power doing so. But yeah, I'm not entirely sure what I'm going to do with these. So the main attraction is definitely going to be these. Let's see how many I actually got. 2, 4, 6, 8, 10. Only 10 of them. I thought I got more. And I have no idea about the quality of these LEDs. They seem to be good, they've gotten some good reviews, but yeah, this one's got a dark spot in it. I hope that's not a short. I haven't looked at them before. And now I'm just looking at them through a viewfinder, so that's not a whole lot better. But they seem to be very easy to mount these. That's why I chose this model over the Star model, because these come with a proper metal backplane instead of a PCB. So I think they're going to be a lot less prone to cracking and so forth when I mount them to some kind of aluminium railing in order to get them to stick to my roof and cool them, of course. And at the moment my lighting system down here in the workshop is quite abhorrent, because it's just a few lamps stuck to the ceiling. They're hanging from those hooks there in some old Cat 5 wiring, and what used to be one of those lamps back there, but the footplate fell off of it, so I just repurposed it. And these lights are pretty standard CFL lights. They aren't too cheap actually, they are proper Osram or Philips ones, but they have this horrible greenish light which pretty much every CFL you're gonna get here in Finland has. And I've got a incandescent light there as well, just for photographs and such. Anyway, let's test a few of these LEDs and see just how well they work. Testing the power supply, and it seems to be within spec, as you'd expect from me. Well, alright, so I've hooked my LED up with my multimeters in series measuring the current, and I've set my LED driver to 150 milliamps. And let me just check the polarity, and yep, let's see how much light this thing makes at 150 milliamps. If it makes light. Oh wow. That is bright. That is extremely bright. Oh god, I can't even see the meter anymore. That's 200 milliamps. Oh jeez. Wow. I was not prepared for that amount of light. Oh wow. This LED is just squeezed down to this heatsink and put a dab of cooling paste. It didn't seem to get hot at all. Wow. I am amazed. The whole jig drew 8 watts out of the grid though, so that's kind of disappointing, but well, actually let me count the power of that. Okay, so I hooked a voltmeter up across the LED and it's reading 27 volts at about 200 milliamps, and that makes about 5.5 watts into the LED. So with the entire rig drawing 8 watts from the grid, that's actually quite good. We're way above 50% efficiency going from the grid to the LED, and that is quite impressive. And the best part is it's probably going to get even more efficient once I add more LEDs and drivers. I'm still taken ablaze by just the pure amount of light you get out of this little, very cheap LED. I can't believe it. Wow. Alright, let's try the 300 milliamp setting. I am afraid to look at it. Drawing 13 watts from the grid, and God, is that bright. Wow. Oh, it looks even more bright on the camera. Wow. From one single LED, that is impressive. I mean, it's way over there on the bench and it's making shadows right bar the frickin' window in the other end of the room. That's, well, maybe 3 or 4 meters away. It's kind of hard to get the scale of this room on camera because it's weirdly shaped. But wow. for an LED that costs a couple of dollars, that is amazing. And I really like the color temperature of it. It's specified to be 6 to 7,000 Kelvin, and I was afraid that they'd be a lot colder than that, maybe 8 or 9,000 like cheap LEDs, but this really seems to be around what it's specified to be, and it's exactly daylight color temperature offers light. This is going to be amazing. Wow. And just for curiosity, I've jabbed its thermocouple to the back of this LED with no heatsink attached. So let's see how hot it gets after some amount of runtime. This meter's now measuring current, and it's set to the 300 mA mode again. Don't want to let it get over 40 degrees or so. Yeah, there we go. Not surprisingly, these things definitely need a heatsink, and it doesn't seem to have too good thermal contact to the actual backplate as well, seeing how the temperature is still rising. Now, as for the build quality of the $4 LED drivers, it's really nothing spectacular. The soldering quality is fairly decent. I've looked these boards over, but they haven't actually cleaned the boards, so they don't look very good, especially not on the backside. But the actual soldered joints themselves seem to be of okay quality. I've taken out 5 of these boards in total after the packaging, out of the 10 or so I bought, and I haven't spotted any bad solder joints yet. The connectors seem to be of okay quality, they don't seem to be falling apart, and these are based on a off-brand version of the A6211 chip, which has gotten pretty good reviews from what I've seen. But as for the construction, I'd wager they've got all these current sense resistors here, 1.3 ohms, and these jumpers just to decide how many resistors you're going to go through. I haven't reverse engineered the board properly, but I don't see how else they would do that. So I might test the efficiency of these boards. It's quoted to be the same as in the datasheet of the driver IC, so it should be around 86%, I think, up to almost 90% under really ideal circumstances. But all in all, I can't really see anything wrong with these boards, although they do come with a generic 220 microfarad electrolytic capacitor of 50 volts. And given that these boards are designed to run at up to 48 volts, I'd probably change this for a 63 volt part of a proper brand. But aside from that, they look really good. The power supply I got was a Meanwhile LPC 60 1400 60 watt power supply, IP67 class, so it's waterproof and dust proof and everything proof pretty much. Sadly though, it's an unbreakable brick that you're never gonna get into, so there's not a whole lot to say about it. I think it's specified for 87% efficiency on the most loads, so it should be a fairly high quality power supply. It feels good, it's very solid, feels heavy in your hands, and since it's a brand name product, I don't think it's gonna have any problems whatsoever. Probably very high build quality inside, and one of the prime features of this power supply is it's supposed to be properly current regulated, so if you go over the 1400 milliamp spec on it, it's supposed to limit to 1400 milliamps and just drop the voltage, so If you got a huge LED that just needs 30 something volts and will eat that 1.5 amp without a problem, then you should be able to just hook your LED up to this power supply without a regulator board. Okay, so another thing I'm curious to find out about it with these LEDs is just how uniform the voltage drops are, so that I can have an idea about what kind of equalizing resistors to use if I'm going to run more than one in parallel on a single LED driver. So the way I'm going to test that, kind of crudely, is to just test every LED, and I've got a simple setup. I've got the power supply going through a switch to an LED driver, which is clipped onto an LED, and I've got my multimeter probes hooked up, and my meter is going to be set in min-max average mode, and it's going to capture the maximum voltage drop across the LED when I give it a short pulse. 28.436 volts in that one. And there we go, all 10 LEDs tested, and there was quite a bit of variance. The lowest being at, let's see, 28.394 I think, and the highest being over 30 volts. These are 9 diodes in series. I'm gonna have to try and hook a few of these up in parallel and see just how uneven the current draw is. Okay, so I've now hooked up the highest drop LED straight up in parallel with the lowest drop one, and I've got my meter set to measure current, and I'm going to bridge the gap between them with the meter. So I know we've got 300 milliamps current or thereabouts coming out of the driver, so if these LEDs work fine in parallel, we should see a current of about 150 milliamps going to this LED. This is the high drop LED. Let's see. Yeah. This LED used almost 200 milliamps, while this one only got 100 milliamps, so this one is dissipating twice as much power. That's going to be a problem. So this time I've hooked up two much more similar LEDs, LEDs number 1 and 2, which had both about 28.4 volts of drop. So let's see if we can run these in parallel without resistors. Now that's a lot better. They are dividing the power almost perfectly equally. So I'm just going to have to bin these LEDs. And there we have it. A finished little up to 40 watt LED test module. The 4 LEDs are just wired up in parallel with the lowest voltage drop one here at the end, so that if there's any voltage drop in the cables, it'll be in its favour. So I've got my driver set to 300 milliamps, so even if everything goes through one LED it won't burn. Let's see how it looks. That looks pretty nice and uniform, on the camera at least. Can't look at them in real life. So maybe we can up the current a bit. Okay, we're now at 450 milliamps. Still looking nice and uniform. Very nice and uniform. 600. Okay, 900 milliamps go. Very nice and uniform, extremely bright. I'm probably going to leave this rig running for a while and monitor the temperature of each LED to make sure that the current is somewhat equal. If I don't really care if they're exactly equal, but as long as they aren't getting uneven enough current for it to be noticed with a thermocouple, I'm happy. So I'll check in after that. And at these settings we're getting about 27.35 volts into the LEDs at 920 milliamps, and we're drawing 31 watts from the grid, which gives us a total power efficiency of 81%, which definitely is not bad. And if we go through the LEDs with a thermocouple, we can see that they're all about 35 degrees. These LEDs are definitely not very unevenly distributed. And as for the driver board, at 900 milliamps, it's not getting very hot at all. So I increased the current to about 1.2 amps. According to the board, I haven't actually measured it. And I've left the LEDs run for about half an hour, and they've reached pretty stable state at around 47 degrees. I'm not sure if you're going to be able to see that, but I'm measuring the hottest one right at the base of the LED, essentially inside its heat spreader. So this is pretty much a worst case scenario, since the heatsink doesn't get any airflow whatsoever, just sitting on the bench. So this is a pretty decent setup for running 1.2 amps through these LEDs. And if I take and probe around and check the different ones, we will notice that there really isn't much of a temperature difference between them at all, which makes me very happy, because it means that I can probably reasonably well run these LEDs without any kind of resistors installed in parallel, even if there's a 0.3 volt difference between the different LEDs or so. And that's a good thing, because that means I don't have to build as much stuff, and I don't have to sacrifice efficiency in order to get the LEDs to run cool. The reason I don't run them in series is because these LEDs have a 30 volt drop across each, and these drivers can only handle 48 volts. And as for a driver, it gets pretty warm at 1.2 amps, but if we probe right underneath the main IC, it isn't catastrophically hot. Pretty hot, but it is manageable. If this went up to about 8 degrees or so, I'd start getting concerned, but 67, that's fine. Okay, so now that I know that I can drive these LEDs quite hard on a heatsink this size, I'm going to ruin all these nice Pentium 3 processors and try and mount 2 LEDs per heatsink on these. And if anyone's curious, these processors came out of old Compaq workstations. They are 500 MHz units, I think. Could be 866. Yeah, they're 866 MHz Pentium 3s. And they were passively cooled, and one of these makes about 20 watts, so I should have a fair chance of cooling two 10 watt LEDs being driven at maybe 7, 8 watts with one of these heatsinks. And after I'm done mounting all my LEDs to those, it shouldn't take too long, I'm going to come up with some way of suspending them up here to replace those lamps there. And that's the part I'm kind of concerned about, because I can't very well drill into this old concrete roof. It just doesn't really take drilling too well. It's a messy business, and it's very soft material, so you can't really put any screws properly into it. You can see I've done that with the lamp here, and it's all wonky already. So I'm probably gonna end up taking my bar and putting some cable on it to get it back a bit and tying it to the lamp. It can be made kind of neatly if I use some thin wire. So after doing that, I'll just suspend my LED light from the nice round steel bar here. Whew, and there we go. I ended up binning the LEDs into two groups, and we've got group 1 here, which is 28.106 to 28.477 volts, or a total difference of 371 millivolts. And we've got group 2 here, which is the higher voltage group, which is 28.678 to 29.112, with a total difference of 434 millivolts. So I tested the LEDs at 0.3 volts differential about, so I'm hoping that 0.4 won't be a big problem. I've got them grouped so that the highest voltage drop is here, closest to the driver, and the lowest voltage drop is over here, with a bit of wire in between. So with a bit of luck, that wire will serve as just a little bit of an equalization resistor to give this to essentially let a bit of a difference drop in this hair cable. It's pretty thin cable, it's just normal Cat 5 cable, so I'm not expecting any miracles, but it's better than nothing. Anyway, I've got the regulators or driver set to 150 milliamps and we're ready for our first test. So here we go. And we're down to smoke. That looks quite alright if you ask me. Man, even at a total of 300 milliamps between all 8 LEDs, they are still far too bright to look at. I am still so incredibly surprised by the efficiency of these cheapo Shure Electronics LEDs. Very surprised. Oh well, we're drawing 15 watts from the grid, so I suppose, well yeah, there's about 10 watts in total going on, so there's still quite a bit of light. Anyway, I'm gonna probe around a bit and make sure that everything's okay, and then we'll step off the power. Okay, everything seemed so good at 150 milliamps, so I'm gonna jump straight up to 1.25 amps. However, something I noticed is these jumpers you get with these LED drivers are of horrible quality. They fall apart if you just touch them the wrong way. And since these are actually current carrying, they are just wired in series with the sense resistors on the board. I would strongly recommend replacing these jumpers if you're gonna get one of these LED drivers, because the last thing you want is a bad connection in there. Anyway, 1.25 amps per driver. Let's go. Oh, and I got myself some Ray-Bans. Not that they really do much. That didn't look like over an amp, that's for sure. We're drawing 50 watts from the grid, so that's maybe 20 watts per LED bar, which is a lot less than it should be. Aha, I found the problem. we're already drawing 1.4 amps out of our 1.4 amp power supply. We've definitely got a problem. But we're not here to have problems, are we? I anticipated this, and I've prepared two laptop power supplies wired in series for a nice stable 38 volts. Both ungrounded, of course. So at 180 watts this should do. Okay, so let's see if we can get our full 10,050 milliamps out of this rig. Now that looks a lot better. No more 30 volts out of the power supply. Well, I must say, that's pretty bright. I've been probing around the temperatures of these LEDs, and the temperature range we have is very good. I'm currently probing the hottest one, and it's at 46.3 degrees. And the coldest one is 44. So I've managed to very well balance the load between the LEDs. I was afraid that would be a problem, but clearly not. But I don't think there's enough thermal connection between the two LEDs to even out the temperature enough for it to invalidate the measurements. So I'm very happy with this. And the temperature is quite alright. You shouldn't run these LEDs much over 50 degrees, but the heatsinks aren't getting very good airflow when they're just sitting on the bench like this, even though these are better than the old test sink. But once I get them up in the ceiling, they're gonna get a lot more cooling since they're just hanging in free air. But yeah. For 80 watts out of the grid, this is quite okay. I've got to measure the power going into the actual LEDs in order to get an idea of our efficiency. Well, I just crunched a couple of numbers and we end up at 75.4% efficiency from the wall socket to the LEDs. So it's not quite as good as the mean well power supply down there on the floor, but it's definitely acceptable. So I'm gonna go ahead and just build these two into the box that I'm gonna build the entire drive electronics into, and be happy with that. It's gonna be a lot nicer than those horrible lights anyway, even though we're not quite as efficient as we could be. But I'm not going to spend $100 on a power supply just to gain 5% efficiency. And there we have it. After quite a bit of experimentation into the wee small hours of morning, I've finally arrived at DIY LED lighting version 0.1, and I decided to mount two of these heatsink modules facing upward to get a bit more spread on the light and make it go out into the room a bit more, because I already, with this setup, even if I turn all the lights to face up, I get enough light down on the bench. I mean, this is a very bright area. Turning the 500 watt light on barely makes a difference around here, because these LEDs are just so damn bright. and the heatsinks do a very good job. The LEDs are at about 40 to 45 degrees, depending on the temperature in the room, and everything pretty much went according to plan, except for all the broken drill bits. I have for the cable used just a Cat 5 cable, which is fairly heavy gauge for what it is, but I could do with replacing that when I finalize the project, which is going to be in some time, because I know I'm gonna need my bench soon, so I need it kind of neat. What is not neat, however, is the version 0.1 drive electronics, because I just stuck them loosely into an old CD spindle with the two laptop chargers somewhere back there, hooked up to an extension cord. Yeah, the one that's been cut in half there, and just coming out into the strip on my bench, which isn't even UPS'd. So if the power goes out, I'm in the dark. But it's good enough for now. And I suppose I'll make a few more videos once this project gets along further. I've still got to install a few 3 watt LEDs around here, warm white ones, to give me a bit of ambience while I'm using the computer at night. And I'm planning on putting another 10 watt LED somewhere up here back in the ceiling to give a bit of flooding to just the rest of the room. Well, I'm going to use 2 LEDs, and then after I get that done, I'm just going to keep on using this system for a while and maybe order a few more LEDs to just get the back, the shelves and this area lit up. And on a side note, I might also make an outdoors light, because this area where I blow out all computers and things like that, which I usually do in the middle of the night, well, it used to have a lamp there, but that thing hasn't been there for quite a few years, so that's probably going to be an LED there, but that's for the future. I need to go to the store and return my broken screwdriver, which was causing all those broken drill bits, because the chuck is wobbly. Stupid, crappy €70 drill.